A-Level Paper 2, 2018. Alkanes can be used as fuels. We give an equation for the combustion of heptane C7H16 in excess of oxygen. So in excess of oxygen you get complete combustion, so you get carbon dioxide and water. Incomplete combustion gives carbon monoxide and water, or carbon and water. But in this case we're going to get carbon dioxide and water, so we have C7H16 plus O2 gives CO2 and water, and then we need to balance it. 7 C's, 7 CO2s, 16 H's, 8 H2O to get the 16 H's. Then I've got 14 O's, add 18 is 22, so I'll need 11 O2. Heptane can be obtained from the catalytic cracking. Identify a catalyst and a condition and equation for this process. So the catalyst zeolite, the condition is moderate pressure, so you don't need it too high. Moderate pressure, couple of atmospheres is fine, 2 to 3 atmospheres is fine. Hexadecane C16H14 cracking to produce one molecule of heptane, one molecule of cyclohexane, and one other product. So we've got C16H34 makes heptane, so hept is 7, so 7, double it is 14, add 2 is 16, so that's heptane. One molecule of cyclohexane. Cyclohexane is C6H12. Remember, it's got the general formula of an alkene, so you double it, C6H12, double the 6 to make a 12, because it's in a cyclic structure. And then one other product, and you can work out what that's going to be. Let's just check. 7 add 6 is 13, 16 C's on the left, so I've got 3. 16 add 12 is 28, 34, 28 take away, 34 take away 28 is 6, so I'm going to make propene. Alkenes can be used in free radical substitution reactions to produce haloalkanes. Give equations for the propagation steps in the reaction of butane to form 2-chlorobutane. So I've got Cl dot, and I've got butane, CH3, CH2, CH2, CH3. You always make HCl, always, and then that tells you what else you can make. So I'm going to make butane, but I'm going to remove an H from somewhere and leave a dot on the carbon that's lost its H. So I'm going to come back to that and work out why it's on carbon number 2. CH3, CH2, CH2 adds Cl2. Always remakes a radical, so that's always remade a catalyst in the reaction, and then the Cl goes on to the point where the dots spin. So that is 2-chlorobutane, and it says here I'm making 2-chlorobutane, so the dot is there where it's short of a bond, and the dot is there where it's short of a bond. So I've put it onto that one there, removed the H from there, and made a dot, an unbonded electron, on carbon number 2, because that's where I want my Cl to be, because it specifies that I'm making 2-chlorobutane. Chlorofluorocarbons are a group of halogenoalkanes currently banned in many countries. The structure of a CFC is shown below. So I've got 3 C's and 3 F's. Identify the radical produced from the CFC that may be responsible for the depletion of ozone in the atmosphere. Explain with the aid of equations why a single radical can cause the depletion of many molecules of ozone. So the radical is a Cl dot. You always make a Cl dot, so a Cl dot, and the explanation is that if I produce the equations for these, it says explain with the aid of equations. I've got a Cl dot plus O3 is ozone. The only other form of oxygen that there is O2, so that leaves Cl and O and a dot here. I'm going to balance the equation. This radical will react again. ClO dot with more O3 again makes O2, and this time, because I've got 4 O's on the left, I can balance it with 2 O2's, and then that makes a Cl dot again. So the Cl dot is regenerated, and that's why one single radical can cause the decomposition of many moles of ozone, because it's regenerated, and it causes this chain reaction to keep on decomposing ozone.